Hi everyone, welcome again to this video of differential equation. So in this video I will show you how to use the properties of Laplace transform, which is that first shifting theorem, to solve the differential equation. Let's say we have the function of ft is equal to e to the power of at ft. So from the definition of the Laplace transform of again, I still have difficult to write down the Laplace notation. So if you have the Laplace of ft is equal to fs, which is that from the integration of e to the power of minus st ft dt from 0 to infinity. Okay, so from here, if we got this one by using the definition, we integrate we multiply the function with the e for minus st, and then we integrate from 0 to infinity, we will got fs. But by first shifting theorem, the Laplace transform of the function in the form of e at ft, this one is equal to f s minus a. Okay, remember, Laplace transform of ft, we got f s, but Laplace transform of this form of function, we got the f s minus a. So how to get this one? Let me show a little bit step to prove of the first shifting theorem. Again, we back to the definition. We have the function e power of at and ft. This one is the function. So Laplace transform of e at ft is equal to the integration from 0 to infinity e to the power of minus st multiplied by this one, which is that e at ft dt. So we can simplify the integration of 0 to infinity e to the power of minus s plus a t ft dt. Where I need to write down. Okay. Maybe a little bit here, so we can put right down here to 0 to infinity. This one we can write down as e to the power of minus s minus a ft dt. Okay, so I go to the blank screen. I think it's better. Again, where I can start. The integration of e minus s minus a ft from 0 to infinity. Okay, if we compare for the general Laplace transform, the integration of 0 to infinity e minus st ft, this one is equal to fs. So let's say we put p is equal to s minus a. So we got the integration of 0 to infinity e to the power of minus p, this one have t here, t f t dt. So looks like similar here. So from here basically we can write down this one is S here, red color, this one is S, and this one is S, you see. So if we got this one, we can write down as F P. Okay, looks like similar because we compare this one with this one, and this P is FP. So P is equal to S minus A, so we got F S minus A. That's how to prove the first shifting theorem. Okay, then let we look at the example so that it's become more clear to all of you. It's very easy, even though the proven looks like quite tricky, but in terms of application, it's very easy. So here we have the function ft is equal to e to the power 3t cos omega t. Let me compare from the definition of the first shifting, which is that ft is equal to e at ft. So from this comparison, we will have a is equal to 3, this one, we compare this one, and ft is equal to cos omega t, which is this one. So from here, we just need to Laplace transform the Laplace transform of this one, which is that Laplace transform of ft here is equal to Laplace transform of cos omega t is equal to we transform this equation, it become s minus s squared plus omega squared. How you get this one? You need to refer to the table that we discussed or we looked in the previous video. This one is equal to fs, but the solution of this one is fs minus a. So fs minus a is equal to, we take this one s over, we just replace s here with the s, s here with the s minus a here, which is that a is 3, so we got s minus 3 over s minus 3 squared plus omega squared. That's all, very easy. Let we look at the other examples. Again, we have e or minus 2t sine hyperbolic omega t. Then from here, a is equal to minus 2, and then ft is equal to sine hyperbolic omega t. So Laplace transform of ft is equal to the Laplace transform of sine hyperbolic omega t, which is that equal to omega over s squared minus omega squared. This one is equal to fs, but if you want to have the solution of fs minus a, just we replace s here to s minus a, which is that omega over s minus 2 plus omega squared is equal to this one, which is s plus 2 squared plus omega squared. Okay, you got some idea how to solve or how to use the first shifting theorem. Let we look at other examples. We have here ft is equal to t cubed e to the power of 3t. So from here, write in the good way, square e to the power of 3t. And then if you compare, you got here a is equal to 3, which said this one is a, and then ft is equal to this one, t cube. So we just solve transform of ft, which is the Laplace transform of t cube. This one is equal to 3 factorial over s to the power of 4 is equal to fs. But f s minus a, just replace the s with the s minus a. Since a is 3, that this one is equal to 3 factorial over s minus a is 3 over 4 equal to 3 factorial is 6. 6 over s minus 3 over 4. So that's how we use the first shifting theorem. So hopefully you can get some idea and try to look at the exercise, and you can easily understand the first shifting theorem.